Today we're learning about vertex form. And vertex form of quadratic is another way to write the equation and makes it easier to graph. And so vertex form, the general form is y equals a times x minus h quantity squared plus k. Okay. Now, this looks really different from what we're used to, but it gives a lot of information right off the bat. First of all, this a value is exactly the same as the a value in y equals ax squared plus bx plus c. These a's are the same. So if we know this a value, we know the stretch. Secondly, I want to point out we have x minus h, okay? That minus sign is part of the equation. So it's minus h. That h, if we're talking about our vertex, the h, it is the x value of our vertex, which makes our k the y value of the vertex, okay? H is the x value, y is the k value. You need to remember, though, this negative is part of the equation, not part of the h. Let's take a look at an example. The example of y equals x minus 2 squared minus 3. Okay, x minus 2 squared minus 3. So in this case, our a is just 1. A equals 1. H, this is x minus 2. So h equals a positive 2. You can think of it, h being the opposite of what you see here. We have a negative 2 or minus 2, so this is a positive 2. H is 2. And then k is exactly what you see. So that's negative 3. Okay, so a equals 1, h equals 2, k equals negative 3. So right off the bat, we know our vertex. Our vertex is 0.2, negative 3. 0.2, negative 3. So now we have that. Let's go ahead and graph. Okay, so we have the 0.2, negative 3. And because a is 1, there's no additional stretch, so we can just use the 149 example that we've seen before. So as we get 1 away, we go 1 up. As we go 2 away, we're 4 above the vertex. 3 away, we're 9 above the vertex, and so on and so forth. Use that line of symmetry to fill in the other side. And here we have our parabola. Those who are still a little confused, the height of this, which is 1 away, is 1 tall. The height of this, which is 2 away, is 4 tall. The height of this, which is 3 away, is 9 tall. Okay. The next one would be 16, then that one after that would be 25. That a value just manipulates how much taller it is. We'll see that again here in a minute. The key thing here, we've seen a before, is identifying h and k, because if we know h and k, we know our vertex. That's one big advantage of vertex form over standard form. We know the vertex just by looking at it. We don't have to calculate anything. Let's take a look at another example. Here we're going to have y equals negative x plus 3 squared plus 2. So in this example, our a is negative 1. Okay, our a is negative 1. H, remember, this would be x minus negative 3. So negative 3 is the opposite of what we see here. Negative 3, and then k is 2. Okay. So H and K, remember H and K are our vertex. So our vertex here is -3, 2. -3, 2. Let's graph that. So -3, 2. Now, our stretch is -1, which means our parabola is opening down. We know that because it's negative. As negative, it opens down. Okay. But our pattern of 1, 4, 9, 16 still holds here. So as we go 1 away, we're going down 1. As we're 2 away, we're 4 below the vertex. As we get 3 away, we're 9 below the vertex. Now I'm going to use line symmetry to pick out the other side. Okay. As we're 1 away, we're 1 below the vertex. As we're 2 away, we're 4 below the vertex. As we're 3 away, we're 9 below the vertex. Okay. Let's move on to another example. This one's going to be y equals 1/2 times x minus 2 quantity squared minus 4. Let's identify A, H, and K. A equals 1/2. H equals opposite of what we see here, 2. And K equals what we see here, -4. Okay. So A of 1/2, that's going to affect our pattern. We'll take a look at that in just a moment. Our vertex is the point 2, -4. Okay. Point 2, -4. -4. Okay. So we have our pattern of 1, 4, 9, 16. I'll even go 25. If we multiply 1/2 times each of these, 1/2 times 1 is 1/2. 1/2 times 4 is 2. 1/2 times 9 is 4.5. 1/2 times 16 is 8. 1/2 times 25 is 12.5. Okay. And so these are the distances above the vertex. So to go 1 away, we're going to be going up 1/2 as opposed to 1. As we go 2 away, we're going up 2 as opposed to 4. So we get 3 away, we're going up 4.5 as opposed to 9. We get 4 away, we're going up 8 as opposed to 16. Okay. So we go 1 away, we're going up 1/2. As we get 2 away, going up 2. As we go 3 away, we're going up 4.5. We go 4 away, we're going up 8. And we use our line of symmetry to fill in the other side. Okay. Mistake right there. Okay. So that's how we can use A, H, and K to help us graph a parabola much faster than we could using standard form and a table of values to graph these points. Okay. But we also need to be able to describe this. Okay. So we have these things called transformations. Transformations. And we've seen transformations before in terms of shapes. Now we're going to be talking to them in terms of parabolas. There are really just three types of transformations. The first type is called a translation. Okay. And that is just a horizontal or vertical shift. Okay. These are just our H and K values. Okay. H tells us the horizontal shift. So that should be easier to remember. And K is our vertical shift. K is our vertical shift. So in this previous example, we have a horizontal shift of 2 and a vertical shift of -4. Okay, so you can shift right 2 and down 4. Okay. That's the first one. That's probably the easiest one to understand. The second one is called dilation. Okay, dilation. Okay, and that's just shrink or stretch. Shrink or stretch. Our A value, okay, the absolute value of A tells the dilation. Okay. Okay. So we know if A is big, it's going to be stretching out, stretching vertically. And if A is a fraction, like 1/2, it's going to be getting shorter. You can't see my hands, but it's going to be getting shorter. So in this last example, we could say dilation of 1/2. Dilation of 1/2. Right? Dilation of 1/2. All right. And finally, we have reflection. Reflection. Okay. And that's just the plus or minus nature of A. Okay. Oops. Reflection is just flipping to open up or down. Okay. So the plus or minus nature of A tells us if there's a reflection or not. If A is less than 0, so if A is negative, that means there is a reflection. If A is greater than 0, A is positive, okay, there is no reflection. No reflection. Okay. So looking at our previous examples, let's write the description of our transformations of just our most recent example. Transformation. Okay. So transformation is a word for all three: translation, dilation, reflection. In the previous example, we have a shift right, shift right 2, shift down, oops, shift down 4. Don't, let me rewrite that. Shift down 4. Okay. The negative tells us it's going down. We have dilation of 1/2. And there's no reflection, so we don't need to put anything. Okay. So in our previous example, we had a shift right of 2, down of 4, dilation of 1/2. Okay. All right. I want you to graph this last equation and then tell me the transformations. Okay. We have y equals 2 times x plus 1 squared plus 3. Graph this and then describe the transformations.